Electronically actuated nozzles versus air actuated nozzles. So what are the differences between these two systems? These are two ways of controlling the on-off cycles of the spray nozzles. Firstly, the actuation response times. This is the big key difference. Our electronic nozzles, either the EHPi industrial model or the EHP advanced model, have much faster response times than our air actuated nozzles, the PHP nozzles. So these have response times of between either 50 cycles per second on the EHPi or up to 150 cycles per second on the EHP system. In contrast, the PHP, our air actuated nozzle, can be cycled off under normal circumstances 3 times per second when using spring actuation overcome by air, and with air assistance, this is air shutting them both on and off, you can get that up to about 10 times per second. Still pretty fast and pretty good for most spray systems, but nowhere near as fast as the EHP and EHPi nozzles. So we're talking nearly an order of magnitude or over more order of magnitude faster with those electronic nozzles, and that allows us to do lots of different things with those types of electronic nozzles. Secondly, let's look at cost. Now, the PHP nozzles, the air actuated nozzles, have a distinct advantage in they're an awful lot cheaper than the solenoid control valves. However, they still need to have a solenoid valve added to the cost of the nozzle to do that control, but a single solenoid valve on air actuated nozzles could be used to control multiple nozzles. So the cost of those solenoids can be spread out over all the nozzles on a spray bar. You've got one actuating air supply, and that can be controlled by a single solenoid. We can bring the cost down considerably. The EHP nozzles, in contrast, they have their own integrated solenoid in each of the nozzle bodies. So you've basically got one rapid response valve for each of the nozzles there. That takes the cost of those nozzle bodies up. So there's a distinct cost advantage of the air actuated nozzles. That being said, they are actually more expensive to run because you're using compressed air to run them. So there's the higher running cost there compared to the electronically controlled, which just take a little electrical signal to turn them on directly. So you've got to factor in the running costs. It's not hugely significant for most spray nozzle systems, but it's still there. So much lower capex for the PHP air actuated nozzles compared to the electronically controlled ones, but a slightly higher running cost. Next, let's look at the pressure range. So what pressure ranges can these two types of nozzle cope with? Our electronic nozzles, the EHP, the advanced model, can cope with up to about 17 bar of fluid pressure. It has a very rapidly responding solenoid valve in there. That means it can't be very tightly wound. It can't hold back pressures much above sort of 17 bar. Now, the EHPi model, the industrial model, still electronically actuated. This is slightly tighter wound on the solenoid, which gives it a less rapid response time, but that means it can actually handle up to about 20 bar of fluid pressure, so slightly higher pressure than the more advanced PHP model. Now, let's look at that compared to our pneumatically air actuated nozzle, the PHP. Now, this can handle up to about 41 bar, much bigger pressure range in there, and that gives some advantages when spraying certain types of fluids. So if we're looking at spraying highly viscous fluids, for example, we might need higher pressures to spray them, and that might be out of the range of the electronically controlled nozzles, in which case you're going to need something like an air actuated nozzle to actually perform the spray system. The next big difference is obviously the presence of compressed air. The electronic nozzles don't need a compressed air supply, and the pneumatically controlled nozzles obviously do. So this can be a critical deciding factor in which to go for. If there's good air supply present, that opens up the possibility of having a pneumatically controlled nozzle. If the air isn't there, then you don't have any choice.